Welcome to the Build Better Brains Handbell How-To, where we're going to explode this C4. We're going to disassemble this Schulmerich C4 handbell and take a good look at its anatomy while we're there. Let's ring on! Hey everyone! Now, while we're building our capabilities as handbell musicians, it's important for us to also learn how to care for our instruments too. Fortunately, for both Malmark and Schulmerich handbells, we can do a lot of our own maintenance. In fact, right in their care and maintenance manual, Schulmerich says there need be no reluctance in disassembling your handbells. They have been designed so that you, the customer, can do repair work that will have no effect on the precision tuning of the bells. Let's start by making sure that we have the right tools. Please note that this video focuses on Schulmerich handbells specifically. I will cover Malmark bells in a separate video. For Schulmerich's G2 through F# 3, we'd need a 3/8" hex nut driver. When working on G3 through B5, including this C4, we'll use a 5/16" hex nut driver. And for a C6 through C8, we'd need a 1/4" hex nut driver. We'll also need a 5/32" hex ball head driver, as well as a flathead screwdriver. For quick adjust clappers, you will also need the proper hex key Allen wrench or a flathead screwdriver, depending on when your clapper assemblies were manufactured. These should have been provided to you by Schulmerich when you bought your bells, but if you need them, you can find them with the links in the description below. Finally, while working on handbells, I typically wear nitrile, vinyl, or latex gloves. This is not really required, but it does reduce the amount of cleaning and polishing that you'll need to do later. Remember, cotton gloves offer no particular protection for the castings, and those little grippy dots often leave weird marks, and you'd have to wipe them off anyway. Alright, let's get started. As we go, if you have any questions that I don't answer or suggestions for a future Build Better Brains video, jump in the comments below. Your subscriptions and thumbs up are also important signals to YouTube that this content is helpful to you, and also don't forget to ring that notification bell. As we go, I will make a point to use the proper names of the handbell's components as they appear in the Schulmerich Care and Maintenance Manual. And before we even start disassembly, we can already identify the handle and the handguard. This one specifically is a MasterTouch disc. And of course, this is the bronze casting, and inside is the complete yoke assembly, including the clapper. Schulmerich handbells are held together by one cap screw, which connects the handle to the yoke assembly through the bell casting. For this C4, we'll use the 5/16" hex ball head driver to loosen the cap screw. In a pinch, a 4mm Allen wrench will work for this too. I usually hold on to the base of the yoke assembly with one hand while removing the cap screw. Now that the cap screw is free of the yoke assembly, we can remove the assembly from the inside. Be careful not to lose the yoke spacer, which looks either like a small metal cylindrical washer or like this, a black plastic washer. Now, looking at the handle in detail, we see on this handbell that the handle is one complete molded piece, which is true for all Schulmerich handles in this latest generation as of when this was filmed in 2021. Contrast that to this C4 handle, which is from the first decade of the 21st century. Here, there is a handle loop which is riveted to a plastic handle block here. And looking further back in time, this C4 handle is from the mid-1980s, and the handle loop is riveted to a metal block here instead. For all of these earlier generations, the handle loops for handbells B2 and below are actually screwed to the block rather than riveted. All of these handles are made from polypropylene or a similar plastic, which has excellent durability and moderate flexibility. However, Schulmerich handles from earlier eras use a black plastic that becomes brittle with time, and should be considered for replacement and definitely not used to build bell trees, as they will likely break under the stress. Now, as we continue the handle comparison, notice how this current integrated generation is rounder than earlier riveted handles. This can be more comfortable to hold individually, but several soloists, small ensemble players, and musicians who often use four-in-hand techniques have reported issues with bells rolling around on the table thanks to this change in design. Personally, I like the single-piece design, but as a soloist, I've definitely had problems with runaway bells and four-in-hand pairs blowing apart when they shouldn't. We're therefore holding off on refurbishing these earlier Schulmerich Handbells until the manufacturer releases an improved handle design, which rumor says has been in the works for some time. And hey, if you're watching Schulmerich, I'd really love to help test those new handles. Okay, for all of the handles since the mid-1980s, we find a campaniform icon on the top of the handle, seen here and here. When placed upwards on the table, this assures that we pick up the bell with the strike point facing forward toward the audience in the primary ringing position. We also see that the pitch name is printed here along with the octave number. C5 corresponds to middle C as written on handbell music, which is actually an octave higher than concert C. That's right, handbells are a transposing instrument. In the mid-1990s, Schulmerich introduced the option to have a gold braid pattern on the handles corresponding to the C major diatonic pitches, that is, matching the white keys on the piano. This braid wraps all the way around the end of the handle and makes it easy to recognize these pitches. Compare that to this C sharp 4, the adjacent pitch, and you'll see that it does not have the braid. This makes it easy to differentiate the black key pitches from the white key pitches. The newest generation of handles replaced the more visible gold braid with these kind of stylized Schulmerich S's. I find this harder to spot in the periphery of my vision, which reduces my confidence that I'm reaching for the correct handbell when I'm playing solo literature or anything down in the bass. I'd really like to have the gold braid back on the next generation of handles. Alright, now as we withdraw the cap screw from the handle here, we'll find a Lockwasher inside. Its purpose is to prevent the undesired loosening of the cap screw, which, left unchecked, can cause the handle to wiggle or rotate. It might also allow unwanted buzzing sounds, and eventually the whole bell could just come apart, perhaps damaging it. Schulmerich recommends snugging up the cap screw monthly using the hex ball head driver. Okay, we're going to go ahead and set the handle aside, and now we can look at the hand guard. Until the 80s or 90s, these were flat plastic discs with the pitch name printed on the surface. These were made from the same brittle plastic as those earlier handles we talked about, and as you can see, they also break quite easily. Since then, Schulmerich has introduced these MasterTouch discs, which have a tapered shape to them that is much easier on the hands. As before, the discs show the pitch name, although now the printing is on the underside of the plastic so that it doesn't wear off. And just as we can compare these modern generations of handles, we can also see that the MasterTouch discs were designed to match. The first generation has gold print on a black disc for all pitches. When the gold braid option was introduced for the C major diatonic pitches, the corresponding discs were inverted to have black text on gold discs. And finally, with the newest generation of handles, the discs became a slightly different color of gold, and the Schulmerich name appears on both sides, replacing the previous Schulmerich Carillons Incorporated inscription. Now, let's go ahead and move on from the handguard to the most important part of the bell, the bronze casting itself. And this is a good point to mention that these instruments are provided by Forzando Arts, which offers fully assembled handbells, hand chimes, and related performance equipment to community ensembles, schools, and churches. Check them out at forzando.art/instruments or find the link in the description below. I'd also like to thank Lex for her contributions to the Build Better Brains project. She, along with other patrons, makes all of these videos possible. Find out how to join via Patreon, PayPal, and by way of Forzando Arts at danielrec.com/buildbetterbrains. This project has a variety of support levels, from a few dollars to full-on sponsorships. No matter how much you contribute, know that every cent is critical to supporting these music education videos, and I really do appreciate your help. All right, now back to the bronze casting. At the top here, we find the crown, which is also called the tang. Schulmerich says that this provides greater amplitude, which certainly would contribute to the zesty sound that reminds me of citrus for some reason. Since at least the early 2000s, Schulmerich has etched the pitch name on the top of the tang, which is helpful when you're working with multiple bells from the same set. Older bells are not inscribed, but it's quick and easy to write in the pitch name using a fine tip permanent marker. There are usually two holes on the top of the tang. The larger center hole is where the cap screw passes through. Notice that it is not threaded. The smaller hole, offset from the center, holds an indexing pin. On the top, this pin mates with a hole on the handle or handle block, while on the other side, it connects with a hole on the base of the yoke assembly. This assures that the entire bell is properly aligned when assembled. Earlier versions of Schulmerich bells sometimes do not have index pins or holes, or the pins are the incorrect length, thanks to improper replacement of handguards or handles over the years. Moving down now from the crown, or tang, the casting's top surface is called the dome. From there, we pass around the shoulder to the sidewall of the bell, also called the body or skirt. This is the surface from which the bell's sound emanates, which is why we always try to face the sidewall toward the audience. This is the thinnest portion of the casting, which is why we need to treat it so carefully, especially when marting. Remember, taco height only, and only with C4 and up. At the end of the sidewall is the lip, which encircles the mouth of the casting. For Schulmerich instruments, the entire outside of the bell, from the dome to the shoulder to the sidewall down to the lip, is polished. Compare this to the inside of the mouth, where we see the lathe marks have been left intact. This is different from Malmark's bronze handbells, which are also polished on the inside. Generally, the inside of Schulmerich handbells do not need to be polished, and we should never try to clean the inside of the mouth using one of those polishing cloths with the red jeweler's rouge. That stuff gets into the yoke assembly and all over the clapper, and it's just a mess. Ugh. However, the casting may accumulate dust stains or other marks inside, and when it's fully disassembled like this, it is safe to gently wash the casting with warm water, liquid dish soap, and a clean, soft cloth. Bronze is extremely soft, so do not use anything remotely abrasive, including scouring powder or green scrubby sponges. And before reassembling, be sure that it is rinsed of all detergent and completely dry, especially here at the tang and around the index pin, where water may be easily trapped. Now, as we finish our tour of the casting, we should be able to find a vertical line scribed against the lathe marks inside. This is an intentional inscription placed there by the factory to indicate the casting strike point. This is the location on the casting which will produce the most ideal tone and timbre. When properly assembled, the clapper should strike exactly here. When the bell is resting and right side up on the table, with the campaniform on top, the strike point will be on the table side of the bell, and then when lifted, the strike point faces away from the musician and toward the audience. Now, moving inside of the casting is the next component, and that, of course, is that yoke spacer that we set aside earlier. This critical component assures that the yoke itself is not resting against the inside of the casting's dome, where it would interfere with the free vibration of the casting. And finally, we've arrived at the yoke assembly, which includes the clapper. Let's start here at the clapper end with this, the clapper head. Schulmerich offers two styles of clappers. This is a select-to-strike clapper, which can be adjusted so that any portion of the clapper's circumference can be set to strike the inside of the casting. The other style is called a quick adjust clapper, which is what we find on this yoke assembly from the inside of an E5 handbell in another set. Current quick adjust clappers can be easily identified visually by the hex shoulder screw on the end, although this is a clapper from the mid-1980s, and so it has a flathead shoulder screw, which at first glance looks like the flathead clapper restraining screw on the select-to-strike clapper. However, they are different, as I will explain. The definite visual giveaway between the two clapper styles is that a quick adjust clapper has this detent plate, which interfaces with the back of the clapper head, allowing it to click into one of 6 positions when rotated. These positions correspond with the hard, medium, and soft markings on the head, which should give us 3 different voicings. One should avoid disassembling a quick adjust clapper unless absolutely necessary, so I will just explain that the clapper head rotation is enabled by the clapper shoulder screw, which sits atop a wave spring and a bushing inside of the clapper head. Together, they assure that the head is attached to the clapper shaft and firmly seated against that detent plate, while still allowing the clapper head to be freely twisted by hand. In contrast, the select-to-strike clapper assembly is much simpler. Here, a flathead clapper restraining screw passes through the clapper head and a lockwasher to secure the head to the shaft, preventing the head from spinning freely. By simply loosening the select-to-strike clapper's restraining screw, the head can be adjusted by the smallest of increments to find the proper voicing, consistent with that pitch's neighbors. On the other hand, those quick adjust clappers are essentially limited to 3 voicings, and as such, they're not allowed the same precision and consistency of voicing across a range of pitches as permitted by these select-to-strike clappers. But that's a topic for another video. So here I've removed that restraining screw, and here is that lock washer, which sits behind the clapper head. Now, we're going to move to the opposite end of the clapper shaft. We find the black restraining spring, which is formed from pelython. It's a moderately flexible material in a bow-like shape, which interfaces with the anti-friction washers, neoprene bumpers, and stop nuts mounted on these studs, which help control the swing of the clapper as well as the force required to ring the bell. Restraining springs do age and become hard and brittle, with replacement eventually being required. After removing the stop nuts, neoprene bumpers, and anti-friction washers, by twisting, not by pulling, we can remove the restraining spring by sliding it from the shaft. The restraining spring fits very snugly by design, so it will require some gentle firmness. Alright, now, below the restraining spring is the shaft block, which is suspended inside of the U-shaped yoke with this metal axle. These white nylon bushings assure that the shaft block does not rub against the yoke and reduces friction between the block, axle, and yoke. Protruding from the yoke on either side of the shaft block, of course, are these studs that we already talked about. On the back of the yoke, we see the threaded middle hole where the cap screw comes through from the yoke spacer, casting, and handle. And the smaller hole matches up to the other end of the index pin. And if you ever wanted to see what a fully exploded C4 looks like, there it is! If this has been helpful, please consider joining the Build Better Brains project at danielreck.com/buildbetterbrains. Your contributions, no matter the amount, make a big difference. They are what make these videos possible, and I thank you. Now, if only I knew how to put this back together. A cliffhanger. You'd better subscribe and ring that notification bell to see how this turns out. Until then, ring on? We'll find a lock washer And I just dropped the stupid thing. From the handle, we'll find a... Schulmerich has introduced these for the C major diaponic pitches.